Okay, so we've got a question here, log of 1 minus I, and I've written here principal log. Now we know we're looking for the principal log because we've got a capital L here. If we had a lowercase l, then when we're looking for the logarithm of this, there's infinite many solutions, because in complex analysis, when we have this 1 minus I, I'll draw that on the graph here. So 1 minus I is 1 minus I, so that's the point we're interested in. So to get to that point from the real axis, that's the first time we hit that point. Now if we go around the circle with the same modulus, we come round again, there's another solution, and again there's another solution, so we can just keep going around forever and ever and ever. There's infinite many solutions, so we call it the principal log when we're just taking the first main one there, that's between the two positive and minus pi. So that leads me on now to working out where is this point. So this point here, what we're looking for now is the modulus, that's distance from the origin, and also the angle from the positive real axis. So we're looking for this angle here, phi. So phi would equal, so as that's equal sides from Pythagoras and from the unit circle, we'll know that this phi is minus pi over 4. Next thing we're interested in is the length. We'll call that alpha. So now from Pythagoras again, it's the square root of the length of both sides. That's a 1, that's a 1. So 1 squared plus 1 squared. So that's square root of 2. Okay, how are we going to attack this log of 1 minus I? So what we say is, log of 1 minus I is the logarithm, open brackets, and then take the modulus of the input, which is 1 minus I. Sorry, let's just make that a modulus. And then we add I times the argument, again capital A is the principal argument, as we discussed here, that's the first one, of 1 minus I. Okay, now we've already worked out these bits here. Let's just write them in as we symbolise them here. So we could call this one alpha. That's the log of alpha. And plus I times the argument. Plus I times the argument of 1 minus I. So that would be phi, as we call it there. So now we just plug in the values just to break it down. So square root of 2 plus I minus pi over 4. Now we can simplify this up a little bit. This bit is easier, we just change the sign on that. So that will be minus I pi over 4. Log of square root of 2, we can use log properties for that. So log root 2, or right there, is the same as log of 2 to the half. So using log property, bring the half to the front. So that equals 1/2 of log of 2. Okay, so now we can just write this down as log of 2 over 2. And that will give us our answer.